Welcome back, students. This is the Q&A session 25 of JEE Physics. The chapter is current electricity, and the question for this session is written on this board. In this question, we have one electrical circuit, and in this electrical circuit, the potential difference across this 8 ohm resistor is 48 volts. The question is the potential difference across A and B is, we have to find the potential difference across A and B, and there are four options here, and we have to find the correct one. So from this electrical circuit, we can see that this 20 ohm resistor, 30 ohm resistor, and 60 ohm resistor, they are in parallel combination, and this 24 ohm resistor and 8 ohm resistor, they are also in parallel combination. So now let us consider the effective resistance of this 20 ohm, 30 ohm, and 60 ohm resistors be R1. If R1 is the effective resistance of 20 ohm, 30 ohm, and 60 ohm resistances, then 1 by R1 will be equal to 1 by 20 plus 1 by 30 plus 1 by 60. Okay, because as we know that in the parallel combination, that is, for example, if this is an electrical circuit, okay, so this is the external EMF source and this is the electrical circuit where there are three resistors which are connected in parallel. So their effective resistance will be is given by, say if it is R, then 1 by R will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So using this formula, we can now calculate the effective resistance of this 20 ohm, 30 ohm, and 60 ohm resistors. So 1 by R1 will be equal to, I will take the LCM of the LCM, and this LCM is equal to 60. So here I will be getting a 3 plus 2 plus 1, which is equal to 6 by 60, or we can say that R1 is equal to 10 ohms. So the effective resistance of this 20 ohm, 30 ohm, and 60 ohm resistor is 10 ohms. That is, R1 is equal to 10 ohms, and this is the effective resistance of 20 ohm, 30 ohm, and 60 ohm resistors. Okay, now from this electrical circuit which is given in this question, this 24 ohm and 8 ohm resistors, they are also in parallel combination. So if R2 is the effective resistance of 8 ohm and 24 ohm resistors, then 1 by R2 will be equal to 1 by 24 plus 1 by 8, which is equal to 24 is the LCM, so this will be equal to 1 plus 3. So it implies that 1 by R2 is equal to 4 by 24, or R2 will be equal to 6 ohms. That is the equivalent or the effective resistance of this 24 ohm resistor and 8 ohm resistor is equal to 6 ohm. So I will be now writing the value of R2 here as 6 ohms, and this is the effective resistance of 24 ohm and 8 ohm resistors. So now this entire electrical circuit now can now be redrawn as, can be redrawn as, this is the point A, this is the 3 ohm resistor. The effective resistance of this 20 ohm, 30 ohms and 60 ohm resistor was equal to 10 ohm. So I can draw this equivalent. This is equal to 10 ohm. This is the effective resistance of 20 ohm, 30 ohm and 60 ohm resistors. And similarly, the effective resistance of this 24 ohm and 8 ohm resistors was equal to is equal to 6 ohm. So here I can I can draw this effective resistance of this 24 ohm and 8 ohm resistors, and this will be in a series with this 10 ohm resistor, which is the effective resistance of 20 ohm, 30 ohm and 60 ohm resistor. Now then there is now so there is one more resistor which is of which is of 1 ohm, and this there is another resistor here which is of 3 ohm. So in this way now I have um, redrawn this electrical circuit after calculating the effective resistance of this 20 ohm, 30 ohm and 60 ohm resistor, and the effective resistance of this 24 and 8 ohm resistors. Now the effective resistance of this 20 ohm, 30 ohm, 60 ohm and the effective resistance of this 24 ohm and 8 ohm resistors, they are in series. So that's why I have drawn these two effective resistance in series, and these two will be in series with this 3 ohm resistor and this 1 ohm resistor. Now here the potential difference across the 8 ohm resistor is 48 volt. So the potential difference across the effective resistance, that is R2, the potential difference across the effective resistance, that is R2, which is equal to 6 ohm, will be equal to 48 volts. That is the potential difference across the 6 ohm resistor will be equal to 48 volt, because this is the effective this resistance of this 24 ohm and the 8 ohm resistor. And since the potential difference across this 8 ohm resistor is 48 volt, therefore the potential difference across this equivalent resistance of this 24 and 8 ohm resistor will also be equal to 48 volt. Now here if I just consider this equivalent this resistor of 6 ohm, then the current through this current through the 6 ohm resistor will be equal to that is current will be equal to, let us say I, it will be equal to 48 divided by 6, which is equal to 8 ampere, because V is equal to IR. So I will be equal to V upon R. The potential difference across this resistor is 48 volt. The value of resistance is 6 ohm. Therefore, I will be equal to 48 by 6, which is equal to 8 ampere. Now, this is a series circuit, and so since the current which is flowing through this resistor is 8 ampere, therefore the current which will be flowing through this 3 ohm resistor, 10 ohm resistor and the 1 ohm resistor will also be equal to 8 ampere, because in the series circuit the current through all the resistors will be the same. So it implies that current through 3 ohm, 10 ohm and 1 ohm resistors will also be 8 ampere, as all the resistors are in series. Since all these resistors are in series, and since the current through this 6 ohm resistor is 8 ampere, therefore the current through this 3 ohm resistor will be 8 ampere. The current through this 10 ohm resistor will also be equal to 8 ampere. And the current through this 1 ohm resistor will also be equal to 8 ampere. Okay. So now we have to find the potential difference across the point A and B. So what we can do is, now the potential difference we can I can write it here now. The potential difference across A and B will be equal to the potential difference across this 3 ohm resistor plus the potential difference across 10 ohm resistor plus the potential difference across 6 ohm resistor plus the potential difference across 1 ohm resistor. So the potential difference across A and B will be equal to the potential difference across this resistor, that is the 3 ohm resistor, the potential difference across this 10 ohm resistor, the potential difference across this 6 ohm resistor, and the potential difference across this 1 ohm resistor. So the potential difference across A and B is equal to the potential difference across this 3 ohm resistor will be equal to, that is V will be is equal to I into R. So I is equal to 8 ampere and R is 3, so that will be equal to 8 into 3 plus 10 into 8 plus 6 into 8 plus 1 into 8. So this is equal to 24 plus 80 plus 48 plus 8. So this will be equal to this is equal to 24 plus this 8 24 plus 8 is equal to 32, and 32 plus 48, 32 plus 48 plus 80. So this will be equal to 8 and 2 10, and 80 plus 80. 32 plus 48 is equal to 80 plus 80, which is equal to 160 volts. So the potential difference across A and B will be equal to 160 volts. So our correct option is D. So in this question, I think the most important thing was first of all we have to find the equivalent resistance of this 20 ohm, 30 ohm and 60 ohm resistor, because they are in parallel combination. Then we had also found the equivalent resistance of this 24 ohm and 8 ohm resistors also. And then we have redrawn this electrical circuit here, and so after calculating the equivalent resistance of these three resistors and these two resistors, we got this electrical circuit in which this 3 ohm, this equivalent resistance of 20, 30 and 60 ohm, which was equal to 10 ohm, and the equivalent resistance of this 24 ohm and 8 ohm resistor which was equal to 6 ohm, and this 1 ohm, they all are in series. And since the potential difference across this 8 ohm resistor was 48 volt, therefore the potential difference across the equivalent or the effective resistance of this 24 ohm and this 8 ohm resistor will also be will also be equal to 48 volts. So the potential difference across the 6 ohm resistor was equal to 48 volt, and based after that, since the potential difference across this 6 ohm resistor is 48 volt, therefore the current which is flowing through this circuit is equal to 8 ampere. And in the series circuit, so this is a series circuit, in the series circuit the current through all the resistors will be the same. So we have calculated the potential difference across each resistor, and after calculating the potential difference across each resistor, we have calculated the potential difference across A and B by adding all the potential difference across each resistor. So the answer was equal to 160 volt, and the correct option is D. So thank you very much for joining this session, for joining this session 25. And in the next session, I will be continuing with some different type of questions from the same chapter, that is current electricity. So thank you very much again, and have a nice day. Bye.